Solving a linear system of equations graphically. Okay, draw a straight line. In the relations and functions unit, we learned there are many ways to describe a relation. Right? We had arrow diagrams and ordered pairs and tables of values, but one of the most important ways is an equation and a graph. Two different equations showing the relationship between x and y are shown below. So we've got relation 1 and relation 2, which of course we also recognize as functions. To satisfy the equation for relation 1, each y value can be determined by multiplying each x value by 3 and then subtracting 1. That's supposed to be a 1, not a minus 1. And then subtracting 1. To satisfy the equation for relation 2, each y value can be determined by multiplying each x value by 1/2 and then adding 4. So let's graph these relations. We have 3x minus 1, right? Slope y-intercept. Oh, let's pick colors. So 3x minus 1, 1, 2, 3 over 1, 1, 2, 3, up 3 over 1. And we also go 1, 2, down 3, left 1, 1, 2, 3, left 1. And we draw the line. So I'm going to draw a line. I wish I could define a line with double-headed arrows, but oh well. Schnurz. Alright, so there's my line. I'm just going to drag that out a bit. Oh, I guess move them over. It's not a perfect line, but that's good. Label it. So this is y equals 3x minus 1. Graph relation 2 on the grid. Okay, 1/2 x plus 4. So there's 4. 1/2. Go up 1 over 2. Go up 1 over 2. Up 1 over 2. Up 1 over 2. Go down 1 and left 2. Down to the left. Remember, up to the right is the same as down to the left. Draw the line. All right, let's see if I can get a better line. There we go. No, and let's make those arrows obvious. So okay, arrowheads. And hopefully by now you have not lost marks for putting those on when you did the previous test. Okay, so there we go. Now I want a thin line. Label it. So this line is y equals 1/2 x plus 4. Look at both relations described as graphs. What is the only combination of x's and y's, right? So we know that this value of x is 1, y is 2, satisfies this, right? When x is 1, 3 times 1 is 1, minus 1 is 2, you get the 0.12. This value 0,4 satisfies this, but the only value that satisfies both relations is this one right here. So what value, what combination of x, y's? It's 2, 5. So 2, 5 is the only combination of x's and y's that satisfies both equations. It's what we call a solution to the system. So therefore the solution to the system is 2, 5. Use the equations to verify this solution satisfies both equations. So the equation is y equals 3x minus 1. 5 is equal to 3 times 2 minus 1. 5 is equal to 6 minus 1. 5 is equal to 5. Yes, it is. And y is equal to 1/2 x plus plus 4. 5 is equal to 1/2 of 2 plus 4. 5 is equal to 1 plus 4. 5 is equal to 5. True. So these equations are satisfied by this ordered pair, this one point, right? The point of intersection of the two lines. To solve a linear system of equation means to determine values that satisfy both equations. In terms of the graphs of the linear equations, the solution to the system is the point, right? We express a point as an ordered pair that lies on both lines, both graphs. A linear system displayed graphically is a quick way to see the solution visually. Remember to label your graphs. Graph the relation x minus 2y minus 6 equals 0 on the grid provided by determining the x and y intercepts. Okay, x-intercept. You set y equal to 0. I'm taking a shortcut, right? I'm just going to go x minus 6 equals 0, so x equals 6. The x-intercept is 6. And the y-intercept, you set x equal to 0. Okay, that's 0. So I'm going to get negative 2y minus 6 equals 0. Negative 2y is equal to 6. Y is equal to negative 3. Draw the line between those 2 points. I'm going to use my line tool, which I'm going to, I think, set to an arrowhead. Whoops, and I'm going to have enough room here. Okay, I'm going to go through those 2 points. I'm going to do it again. Extend the line. Okay, and we have arrowheads. Alright, let's draw those in. I mean, they're there, but let's make them really explicit. And let's label the line. Okay, so that's x minus 2y minus 6 equals 0. X minus 2y minus 6 equals 0. And I guess I should maybe sort of highlight that. Make this line as purple as can be. Graph the relation x plus 2y minus 2 equals 0 by first rearranging into slope y-intercept form. Alright, what are we starting with? X plus 2y minus 2 equals 0. My y is positive, so I'm going to move everything else over. The x will become negative x, minus 2 becomes plus 2. Divide through by 2, get negative 1/2 x. Make the slope explicit, right? And 2 divided by 2 is 1. So we have y equals negative 1/2 x plus 1. Let's graph that. So we have a y-intercept of 1 and a slope of go down 1, right 2, down 1, right 2, down 1, right 2. That's actually our point of intersection, right? It'll go up 1, left 2, up 1, left 2. I just like drawing lots of points. Okay, let's draw the line. That gives us an arrow. Let's draw the line the other way. So we've got an arrow, and then let's really draw the arrows. And let's see if we can get a straightish line over top of the black line. It's the black line that's important, right? So just remember what you want to do. Make sure you're showing points, especially if there's only 2 of them, and draw, you know, the best line that you can. And let's label that x plus 2y minus 2 is equal to 0. Okay, so we have drawn and labeled the lines. State the solution. The solution is the point of intersection, which will be 4, -1. Or at least it looks like 4, -1. Verify this. One thing with solving graphically is, like, what if it only kind of looks like it, but it isn't really it, so we need to check. So let's do x minus 2y minus 6 equals 0. 4 minus 2 times -1 minus 6 equals 0. 4 plus 2 minus 6 equals 0. 0 equals 0. Check. And the other equation is x plus 2y minus 2 equals 0. 4 plus 2 times -1 minus 2 equals 0. 4 minus 2 minus 2 equals 0. 4 minus 4 equals 0. 0 equals 0. Also a check. So yeah, this is in fact the point of intersection. One thing with solving graphically, especially if we're drawing it by hand, is you really do need to check that. You need to verify your solution. Special cases. Graph the following equations. Y equals 2x plus 4 and y equals 2x minus 5. Okay, so here, let's get some different colors. Y equals 2x plus 4. So there's 4 up 2 over 1. We can also go, of course, down 2 and left 1, and then just keep doing it. It's not like it takes forever to draw in as many points as we have. And I'm just going to kind of freehand this. We'll see how disastrously this... Okay, nope, I'm going to... Control Z, get rid of that. I'm going to draw the line. And then draw the line the other way. Okay, so there's the line, and then let's label that. Y equals 2x plus 4. Let's make nice arrowheads. And the line 2x minus 5, so minus 5, up to right 1, up to right 1, and so on. All the way along, and also down to left 1. And having learned the lesson, let's draw the line. Oh, I'm gonna undo that. I ran out of grid. Gotta watch where you start on the tablet. And let's go the other way. Okay, nice lines. Back to green. Arrows, green arrow, and label the line. Let's do that down here. Y equals 2x minus 5. So there are our two lines. And what's special about these lines? They're parallel. They are parallel. How many points lie on both lines? What we're asking is, where do they meet? Where do they cross? And so, none. Since they're parallel, there are no points that lie on both lines. What is the solution to this system? There is no solution. Remember, solution to a system is the ordered pair, or the point that satisfies both equations. There is no x, y that makes both of these equations true at the same time. Can't draw a straight line. Okay, so parallel lines, no solution. Graph the following equations. Y equals 2x minus 4. Do I have that? Let's just go back. Y equals negative 2x plus 4. Go down to right 1. Slope of negative 2. Down over. Also go up and left. Draw the line. Learn the lesson. We will draw the line. Draw the line the other way. The same line. arrows. Arrows. Label y equals negative 2x plus 4. And draw a line. 6x plus 3y. Okay, well, you know what? Let's go 3y is equal to negative 6x plus 12. So y is negative 2x plus 4. Hey, wait a sec. That's this line. So it's the exact same line. Let's go over it in red. Huh, same line. So what's special about these lines? They are the same line. How many points lie on both lines? Lots. Alright, we don't say lots. We say infinitely many. Infinitely many. What is the solution to this system of equations? Well, there are infinitely many solutions. There are infinitely many solutions, right? Basically, any point that's on this line is a solution to both systems. Since both of these systems, or both of these equations, are really the same line. There's really only one line here. This leads us to types of solutions to a linear system. In order for a system to have only one solution, the slopes of the lines, okay, let's go back and take a quick look. So we've got two special cases. So here we have a solution. Now what happened? Well, these lines have different slopes. So they're going to cross at one point. If the lines have the same slope, then they're parallel lines and they won't intersect. And if the lines have the same slope and the same y-intercept, same slope and same, then they're the same line. So the slopes of the line must be different. If we have different slopes, then we know the lines will cross at one point. So graphically there will be one intersection point. If you have no solution, then the slopes must be the same. The y-intercepts must be different. Graphically, there will be no intersection point, and the lines with the same slope, those lines are parallel. In order to have infinitely many solutions, the slopes must be the same. The y-intercepts must be the same. Graphically, the lines overlap, and they are called coincident lines. Right? Just a fancy way of saying the same line. Alright, was there something else? Hang on. Nope. Using graphing technology to solve a system. Okay, so if we're going to graph, we're going to rearrange the two equations so they're in the form y equals. We'll select y equals on the calculator and enter the equations 1 in y1 and 1 in y2. We'll graph them. Select second calc, arrow down to 5, intersect, and press enter, or just press 5. For me, it's just press 5, right? It's faster. Use the left-right arrow key to move the cursor to the point of intersection of the two graphs. The screen will say first curve, press enter. The screen will say second curve, press enter. The screen will say guess, and because we moved to the point of intersection, that's our guess, we'll press enter, and the answer will appear at the bottom of the screen. So let's give this a try. Given the system, solve the system using graphing technology. So these must be rewritten to be y equals. So this is 3x plus 9. This has to be rewritten. So it's going to be 3y is negative 2x plus 5. So it'll be y equals negative 2/3 x plus 5/3. Okay, let's put those, whoops, I wanted the graph. So we go to y equals. We enter the first graph, 3x plus 9. Hit enter. The second graph, negative 2/3. Negative 2 divided by 3. I just sort of like to separate it off in a bracket. X plus, and again, you don't need to do these. You don't need the brackets, but I just like the way it looks. The window will be the standard window, right? If you just start up your calculator. So the standard window goes from negative 10 to 10 by 1s. We may have to adjust that depending on whether or not we can see the point of intersection, which we can right here. Okay, so next step. So now what you want to do is you want to find the intersection. Go second function and enter the calc menu. Number 5 is intersect. You can arrow down and press enter or just hit 5. First curve, you notice it's asking for that. I see my cursor up here. I'm going to use the left arrow key to move to about the point of intersection. When it says first curve, it's at y1. It's at our first curve, right? So we press enter. It says second curve jumps down to y2, and it's showing you the equation. And again, just press enter. It wants a guess. Now, if you didn't move here, you need to move to this point of intersection. And we press enter. And then we get the intersection, right? Which is at x equals negative 2, y equals 3. All right, so what did we do? Let's summarize that here. Solve the system you state your graphing window. So we said negative 10 to 10 by 1 and negative 10 to 10 by 1. Pretty much always start with the standard window and then adjust. Draw a sketch of the graphs. Okay, what do we got? So we have one graph going like this. And that will be the graph y equals 3x plus 9. And the other graph goes like this. And that's y equals negative 2/3 x plus 5/3. And there's our point of intersection, which was negative 2, 3. So that's the point negative 2, 3. So there's our system of equations, right? Two graphs solved graphically using a graphing calculator. And the solution is an ordered pair. Don't just write down x equals negative 2, y equals 3. Show it as an ordered pair, right? You need parentheses and a comma in between, and that's our solution. State the solution to the following system of equations. Use graphing technology. Round any values to the nearest tenth if necessary. Okay, go to y equals. Let's clear out what we have. Clear, go back up. Y equals negative 4x minus 3. 4x minus 3. Y2, this needs a little rearrangement, right? Y equals 2/3 x plus 17/3. Okay, y2. 2/3, you don't need these brackets, I just like them. 2/3 x plus 17/3. And hit graph. The question is, do we see? Yes, we see the point of intersection, so the standard window will do. Second calc, intersect. Use the right arrow key. First curve, notice it's on y1, so just hit enter. At this point, doing an intersection, you just hit enter 3 times. First curve, second curve, shows you the equation, hit enter. The guess, this is the point, but we're near there, so we're guessing it's near there. Hit enter. And we get 2.6, 7.4. So the solution is 2.6, 7.4. Write it as an ordered pair. Since it fit in the standard window, which is negative 10 to 10 by 1s in both directions, then we are good. This time, okay, let's move over here. One more time. little rearrangement here, right? It's going to be y equals x minus 12. We have to isolate the y. It means moving the x over where it becomes positive, moving the 12 over where it becomes negative. Here, we're going to have to add 1 to both sides. So it'll be y equals negative 1/3 x. I'm just going to rewrite that, right, so I can see the slope. And then I'm adding 1, so it'll be plus 7. Okay, go to y equals, clear out what's in there. So y1 is x minus 12. We have a little symphony in the background. And y equals bracket, negative 1/3 x plus 7. Hit graph. So you can see the intersection is somewhere to the right of 10. So we're going to have to adjust our window. Looks like it happened out about here. Let's take the window out to 20. Hit graph. First curve, second curve, good enough. Okay, second calc, intersect. Again, move to the point of intersection. I'm worried about it being... Okay, there we go. And then hit enter 3 times. 1, 2, 3. Round. I'm not rounding to the nearest tenth. I don't care what it says. It's 14.25, 2.25. Okay, so if we are rounding, it'll be 14.3 and 2.3. Alright, I don't like doing that just because this, I think, is an exact value. So, we went negative 10 to 20 by 1s and negative 10 to 10 by 1s. We could have adjusted this further, but, you know, it satisfies what we've got. It's got the equation showing, so we'll be good with that. 3. To visit the Head Smashed In Buffalo Jumper Interpretive Center near Fort Macleod, Alberta, the admission fee is $5 for a student and $9 for an adult. In 1 hour, 32 people entered the center, and a total of $180 in admission fees was collected. Sam wants to determine how many students and adults visited the center during this time. Label your variables. More define your variables, I think. Define your variables. So let S be the number of students. Students. And let's let A be the number of adults. Number of adults. So if you're solving a system, you have to define your variables. That's always step 1. Then you write a linear system that models this situation. So we know the number of students plus the number of adults is 32. We know that 5S will be the total amount of money we got for students, right? $5 for each student. S is the number of students. 5S is the amount of money collected for the students. 9A, A is the number of adults, times 9 gives us the amount of money, and the total amount of money collected is $180. Solve the system graphically. Okay, so you know what, we're going to have to rewrite this. So we're going to have to go like x plus y equals 32. So students will be x and adults will be y. And y is equal to negative x plus 32. You could also equally, you could also have written y equals 32 minus x. It won't matter. This is 5x plus 9y equals 180, giving us 9y is negative 5x plus 180. Pause. And so y, that's one thing about graphical solution, right? Negative 5/9 x plus 20. Okay, so we have our two equations. This will be y1, and this will be y2. It's likely the solution, well, who knows, you know, it might be outside the window. Okay, I'll turn this on. So what I'm going to do is go zoom 6. I'm going to reset to a standard window. I'm going to go to, whoops, as soon as this is done, I'm going to go to y equals. I'm going to clear out what's in there. So y1, negative x, negative, that's this negative, that's a subtraction and you'll just run into problems, plus 32, and negative 5/9, so me with the brackets again, 5/9 x plus 20, and hit graph. And let's see what happens. We see nothing. Alright, so now we have to decide. So one way to help us is we can go into the table. Now we know that if x goes from 0 to 32, or sorry, if x is 0, remember what x is, right? Number of students. So we could have 0 students, and in that case the y value will be 32 for y1 and 20 for y2. So let's give an idea here. This is the number of students. Well, we can have from 0 to 32, right? And let's go by 2's. Now, y is the number of adults, and so the number of adults can go from 0 to 32 as well. And let's hit graph and see what we get. There we go. Okay, so we have our values, we have our intersection here. So let's go second calc, intersect. Again, I like to move to the point of intersection, which is right there. Hit enter 3 times. So first curve, this is the negative x plus 32. Second curve, negative 5/9x plus 20. And your guess, somewhere around 27 and 5. And it is in fact 27 and 5. So we have our solution. So what we want to do is sketch the graph of your solution. One curve looked like this. One curve started further down and crossed there and looked like that. Label the axes. So at this point we can go back to using students and adults. We're not actually going to put arrows on here, right? Because the values, it's numbers of people, right? And in essence, really, it's a set of points, right? This is really discrete, not continuous, but graphically, this is what's going to happen. And so the solution is S first, 27 students, 5 adults. And we should probably write that down. There are. Because maybe we went the other way. Maybe X was adults and Y was students. Okay, so we need to explicitly state, right? And I think it asks even, Sam wants to determine how many students and adults visited. So in a word problem, you define your variables, you write your system, you solve it, however you're going to solve. In this case, all we know is graphically, and then you write your answer. So there are, oh, here we are. It's down here. Go further. There were 27 students and 5 adults, so probably a class trip. Now, when I solve a word problem, the 4 steps of problem solving: understand. So in this case, what are we trying to find? How are we going to do it? Plan, make a plan. What are we going to do? Well, we're going to come up with the 2 equations. do, solve the system, right? In this case, we did it graphically. So understand, what do we have to do? We have to come up with two equations. Make a plan how we're going to solve it. We're going to solve it graphically. We need to rearrange the equations. We did it. And step 4, very important, is look back. So I have 27 students and 5 adults. Forgetting everything that we did, go back to the context. I have 27 students and I have 5 adults. This is 32 people, and this is 135 plus 45, which is 180. So within the context of the question, and forgetting everything about this, right? Forget about all your variables, forget about all your equations. If these were wrong, we're going to have a different solution, right? This won't add up. We won't have 32 people, and we won't have $180. Okay, so take your answer, take it back to the question itself, forget about everything you did. Don't go substituting into here. It's going to work because that's the system that you solved. If we solved the correct system and solved it correctly, then it will make sense in the context of the question. Okay, and that's what's important in this case. And we are done.